Hello, my name is Menglei Duan. This presentation is for my course project. I entitled it as Characterize Forest Structure of Transitions Between Main Successional Stages. This project is in the field of forestry, ecology, and remote sensing. Okay, let's start. Let me briefly introduce the background first. Tropical dry forests are dominated by deciduous species, such as trees and lianas. Lianas are structural parasites. They combine resources with the host tree. Besides, tropical dry forests provide habitats for wildlife, such as deer, monkeys, and so on. Also, tropical dry forests improve global climate regulation, such as carbon cycle. Traditional strategies usually divided the secondary succession into three deterministic stages: early, intermediate, and late. However, it should be a continuous process. In other words, transitions exist between main successional stages. These transitions have unique forest structure and they show subtle differences. But the gap is we don't know the information of transitions. This project was conducted in a tropical dry forest in Costa Rica. The dataset was collected by a plane mounted with LiDAR sensor. I selected 27 plots along the successional path from intermediate transition to late. It's like a transit. And here is a LiDAR data violation for those 27 plots, and the color scale shows canopy height. From LiDAR data, leaf area density and canopy height can be derived. I plotted them in the line chart, so it looks like the waveform. 5 metrics are used. First, C means centroid, so Cx, Cy means the coordinate of the waveform centroid. And Rg can be calculated using Cx and Cy based on this formula. Besides, P means peak, so Px, Py is the coordinate of the maximum waveform amplitude. I plotted 3 leaf area density vertical profiles and I put it here. So based on this, I calculated 5 metrics of each plot. So in total, that's 27 plots. I summarized those information such as mean value, standard deviation of metrics, and put them in this table. I also ran a NOVA test to see if different stages have significant difference with metrics. The result from ANOVA shows that different stages are not significantly different in px and py. The reason is if we get into the field, we can see all those plots in intermediate, transition, and late are covered by dense shrubs and grasses and short trees. So that's why the peak is at the bottom in leaf area density profile. Besides, I also run pair comparison and I put the result in this table. We can see intermediate and late is significantly different in Cx, Cy, and Rg. Also, late and transition is significantly different in Cy and Rg. Although intermediate and transition doesn't show significant difference in Cx, Cy, and Rg, we can still see the difference in other ways. I also generate volume plots between metrics and the succession. So in this case, Cx is the leaf area density, and the Cy is the canopy height. First of all, we can see there is a decreasing trend in Cx with succession. The reason is the intermediate stage is infested by lianas seriously, so we will overestimate the leaf area density in the intermediate stage. In contrast, there's an increasing trend in Cy with succession. That's easy to understand because trees are growing. This scatter plot between Rg and the leaf area density shows that there's a clear distinction between the intermediate and late stage. However, green triangles show a prominent transitional feature, which is spread among the intermediate and the late stage. This shows the dynamic and the uncertainty of transitions, as we expected. That's all about it. Thanks for your attention.